The kinetic theory of matter states that all matter is made of tiny particles that are in constant motions. The higher the temperature, the faster they move on average. Heavier particles move more slowly than lighter ones at a given temperature. Changes of state using kinetic theory. An import of energy is needed to melt and boil a substance. The energy lessens the force of attraction between particles when the solid melts or liquid boils. Energy is given out when the substance condenses or freezes. This is because the particles are losing some of the energy of their movement, kinetic energy, when condensing or freezing. What happens during melting or boiling? When a substance is heated, particles gain kinetic energy, move faster, overcome the attraction forces between them, and move further apart. What happens during condensing or freezing? When a substance is cool, particles lose kinetic energy, move slower, and come nearer to each other. Solid melts to liquid, liquid boils to gas, gas condenses to liquid, liquid freezes to solid. Heating curve: solid melting, liquid boiling, gas. The heat energy that's supplied used to overcome forces between particles. Increase in vibrations. So, heating curve. Firstly, increasing heat energy increases the vibrations of particles in the solid, so the temperature of the solid increases. Second, the forces of attraction between the particles are weakened enough so that the particles begin to slide over each other. The temperature is constant because the energy supply is going to overcome the forces between the particles instead of raising the temperature. The substance melts. Third, increasing the energy increases the motions of the particles in the liquid, so the temperature of the liquid increases. And then again, the forces of attraction between the particles are weakened enough so that particles move far away from each other. The temperature is constant because the energy supply is going in to overcome the forces between the particles instead of raising the temperature. The substance boils. Increasing the energy increases the speed of the gas particles, so the temperature increases. These gas particles are far away from each other. The shape of a cooling curve is the reverse of that of a heat curve. Why they are pure? They have a fixed and sharp melting point. Cooling curve: gas, condensation, liquid, freezing, solid. How the curve shows pure sample of compound X series. Compound X has a fixed sharp melting point and a fixed sharp boiling point. Effects of temperature and pressure on volume of gas. The temperature of substance is directly proportional to the kinetic energy of the molecules. If the temperature of the gas increases, particles will have more energy and will move around faster. Gas molecules are in a state of continuous motions in all directions, and they are constantly bombarding the wall of a container. The gas particles exert a force on the wall of the container, causing pressure. Pressure of gas is due to particles hitting the inner surface of the container. When temperature of a gas is increased, the pressure of the gas increases because particles gain more kinetic energy, move faster, and hit the sides of the container faster and with stronger force. Particles gain more kinetic energy, move faster, hit the sides of container faster with stronger force. If the gas is compressed into a smaller volume, the molecules get closer together and hit the wall of the container more often, so the pressure increases. The higher the pressure, the closer the particles are to each other. Diffusion. Diffusion does not occur in solid because particles are bonded to one another more strongly than those in liquid and gases. The strong bond prevents them from being able to move relative to one another. Diffusion takes place in gases and in liquids. Explanation using particle theory. Moving randomly, collide, spread out. Gas particles move randomly from perfume particles colliding with each other with other particles in the air until they spread out, causing diffusion. Diffusion is the movement of particles from an area of high concentration to an area of low concentration without the concentration gradient. Particles of liquid bromine gain kinetic energy, move faster, overcome the attraction forces between them. They move from area of high concentration to area of low concentration by diffusion. Rate of diffusion depends on mass. Particles that are lighter, lower molecular mass diffuse faster. Energy at higher temperature, particles gain more kinetic energy, move faster, so they diffuse faster. Nature of the medium: diffusion is faster in gases than in liquids. Light particles diffuse faster than heavier particles. Rate of diffusion is inversely proportional to the molecular mass of particles. Ammonia diffuses faster than HCl. Experiment to show diffusions of ammonia and hydrogen chloride. Hydrogen chloride gas diffuse. White ring of ammonium chloride forms here. Ammonia gas diffuse. Mineral wool with concentrated ammoniac solution. Universal indicator vapor. Mineral wool with concentrated hydrochloric acid. Where the ring forms is NH3G plus HClG2 NH4Cl solid. Ammonium chloride is a solid. Hydrochloric gas diffuses towards NH3, and H3 gas diffuses towards HCl. When two gases make a white solid is formed, NH4Cl. NH3 is lighter than HCl, hence the white solid far from NH3 and closer to HCl. Ammonium chloride is formed. Silver nitrate particles are lighter than ammonium dichromate, so they diffuse faster. When the silver nitrate particles meet the ammonium dichromate particles, they react to form silver dichromate, which is red in color. That's why red solid appear along the line as